From high above, one lake in the north of Tanzania does not look like it belongs on Earth. Great swirls of deep red and rust and salt white spread across the land, as if someone had poured another planet into a basin and left it to bake. By every rule we think we know, a place this extreme should be utterly, silently empty. Lake Natron is the exact opposite. Across the whole continent, few places are this alive, and the spectacle here grows so large you can pick it out from orbit. How that happens is one of the strangest, most beautiful things our planet quietly does. I'll be honest, when you first read the numbers here, your instinct is that nothing could possibly survive in it. Over the next few minutes, I want to walk you through why those numbers are so extreme, and then show you the twist, because the very chemistry we would expect to leave Natron a dead zone is the reason millions of birds are alive today. This is not a story about endings. Think of it instead as a story about impossible beginnings. Start with the water, because the water is unlike almost anything else on the surface of the world. Scientists call this a soda lake, and the soda is not a figure of speech. Natron is loaded with sodium carbonate and sodium bicarbonate, the same family of compounds you would find in washing soda and baking soda, dissolved here at a concentration that almost nowhere else can match. That chemistry pushes the water up to a pH near 10.5. To turn that into something you can actually feel, you are now in the territory of household ammonia. On top of all that, the lake runs hot. Fed by underground springs and cooked by relentless equatorial sun, the surface can climb towards 60 degrees Celsius in places. Picture a shallow, blood-red sea of warm liquid soap stretching to the horizon, shimmering so hard that sky and ground blur into a single haze. All of it is just an ordinary afternoon here. There is even a mineral named after this exact chemistry. Pale crust rings the shoreline and drifts across the surface in floating rafts, rich in a substance called natron, a naturally occurring soda that humans have prized and traded for thousands of years. Long before anyone could explain the chemistry, people gathered this powder from dry lake beds and put it to work. Blended with a little oil, it became one of the oldest soaps in the world. Undiluted, it cleaned teeth and freshened the mouth. Stirred together with sand and melted in a furnace, it helped early craftsmen make glass, and it carried the recipe for a brilliant pigment the ancient world called Egyptian blue. Oddly, the name of the mineral did not come first. The lakes that grow it came first, and we named the powder after the ground that made it. How does any body of water become this alien? Three forces stack on top of one another, and you need all three at once. It helps to zoom out and feel where the lake actually sits. The East African Rift is no quiet green valley. Here is the slow, grinding seam where one continent is splitting into two. A crack thousands of kilometers long that widens by a few millimeters every single year. Give it time enough, and the sea will pour in and turn this whole region into a new ocean floor. Natron rests at the bottom of that wound, in a low, sealed basin where the planet's heat leaks up through hot springs. So the lake is not an accident of bad weather. Rather, it is what happens when you set a pool of water down on one of the most restless places on Earth. Enough about the first force. Second comes the trap. Water arrives from those hot springs and one seasonal river, but almost nothing escapes because no river drains this basin out to the sea. Every drop that flows in can leave only one way, by rising into that furnace of a sky and abandoning its salt behind. Season after season, the salts pile higher and the water grows stranger, never gentler. Then there is the third force, and it is my favorite part of the whole story. Just to the south rises Ol Doinyo Lengai, a volcano the Maasai have always called the Mountain of God. No ordinary mountain stands here. Out of every active volcano on the entire planet, this is the only one that erupts what geologists call natrocarbonatite lava, a bizarre, runny, comparatively cool lava built not from the usual molten rock, but from sodium and carbonate. Fresh from the vent, it pours out almost black, and within hours it weathers to a chalky, ghostly white, as though the mountain were breathing out frost from another world. Rain drags that sodium-rich rock down off the slopes and into the basin, handing the lake the precise recipe that makes it so extreme. Picture the full machine. Just a basin with no exit, under a sun that never quits, fed by the one mountain on Earth that erupts something close to liquid soda. Remove a single piece, and you are left with a forgettable pond. Assemble all three in this one spot, and you get the reddest, most otherworldly water in Africa. Most people expect the story to end right here, with a hostile, lifeless place that nothing could want. Instead, this is where it turns genuinely wonderful. That severe alien lake, the one that reads on paper like a chemistry experiment pushed too far, is the single most important breeding ground on the planet for the lesser flamingo. We are not talking about a handful of stray visitors. Somewhere between 1.5 and 2.5 million of them, around 3/4 of the entire world population of the species, gather at this one improbable lake to raise the next generation. Somewhere that should be a dead end turns out to be, for one of the most graceful birds alive, the beginning of everything. So how do they manage it? These flamingos are built for exactly this water. Their long legs are sheathed in tough, leathery skin, and special glands let them shed the heavy load of salt they take in, so the chemistry that would overwhelm almost anything else barely troubles them. Far out in the middle, on flat little islands of caked salt that appear when the water drops, they pile up small volcano-shaped mounds of mud and lay a single egg on top. Here is their quiet genius. Nothing else can reach them. No jackal, no hyena, no big cat is going to wade kilometers across hot, caustic water to bother a colony. Strangely, the very feature that makes the lake look so forbidding becomes, for a flamingo chick, a moat that no predator will ever cross. A fortress wall built out of pure chemistry. That fortress, though, only exists for part of the year, and timing is everything. Watch the lake across the seasons, and it seems almost to breathe. Rains swell the river, the water rises, and the salt islands vanish under the flood. Then the dry months bake the basin down, the surface retreats, and the little islands surface again like stepping stones. Flamingos read this rhythm with astonishing care. They nest only as the water is falling, in the narrow window when the level sits just right, because if it stands too high, there is no firm crust to build on, and if it sinks too low, the moat thins, and a clever predator might pick its way across. In a wet year, that window may never open at all, and the great colony simply waits. So a breeding season here is not a calendar date. It is a careful bet placed on the weather, and the birds have been winning that bet for a very long time. Better still, and this is the detail I keep turning over in my head, the same alkaline water that seems so unwelcoming happens to be ideal for one particular kind of cyanobacteria, a microscopic blue-green life form, sometimes called Spirulina, that blooms across the lake in staggering quantities. Those blooms are a feast, but how do you eat something that small? Each flamingo feeds with its head turned almost upside down, sweeping that strange downturned bill through the water like a slow scythe. Inside the bill sit rows of tiny comb-like plates, and the bird's thick tongue works like a pump, drawing water in and pushing it back out many times a second. Out flows the water. The microscopic harvest stays behind. Few filters in the whole animal world are this delicate, and this one runs all day long in liquid that would sting your eyes shut. Then comes the color, and the chemistry of it is lovely. Those blue-green cells are loaded with carotenoids, the same broad family of pigments that turns carrots orange and gives salmon its blush. Each bird swallows them by the beakful, and deep inside its body, the liver quietly rebuilds them into rich pink and red molecules that settle into the growing feathers. Hatched chicks start out a plain, dusty gray. Only by eating, season after season, does a bird slowly earn its rose. Brightest individuals tend to be the best fed and the healthiest, So in a real sense, a flamingo wears its own well-being on the outside, painted there by an organism far too small to see. Here is the part that genuinely stops me. That humble blue-green life is no recent arrival on the scene. Its ancestors rank among the oldest living things we know of, microscopic cells that were already busy on this planet billions of years ago. Long before there were birds or trees or anything you could call an animal, cyanobacteria like these were quietly breathing out oxygen, filling an empty sky over hundreds of millions of years until the air itself became something a creature could one day breathe. The same kind of life that helped make the whole planet livable is now, in this one red basin, the thing that feeds and colors a million flamingos. Something older than nearly everything paints the wings of one of the youngest, loveliest things in the sky. Trace the chain all the way down, and it almost feels deliberate. First, a volcano feeds the lake. Its wild chemistry feeds the bacteria. Those bacteria feed the flamingos and paint them rose. And the same water that grows the feast also guards the nursery from anything that might threaten the young. When the breeding season peaks, the colony moves as one. Tens of thousands of gray chicks gather into vast traveling nurseries and cross the flats together under the watch of a few patient adults, a slow pink and gray tide drifting over red ground. Stand close enough, and the experience overwhelms far more than your eyes. Well before the colony swings into view, you can hear it, a low rolling murmur of hundreds of thousands of voices carried across the flats. Heat shivers off the crust in sheets. Pink stretches past the limit of what a person can take in, breaking now and then into ribbons as one section of the flock lifts, wheels, and settles again. No photograph quite carries the weight of it. Scale on this order has to be felt in person, which is part of why the place reads less like a lake and more like one enormous living thing. One more trial waits for the youngest birds, and it is a gentle one. While the chicks are still small and cannot yet fly, the drying flats can leave fresh drinking water a long way off, so the little ones simply set out on foot to find it. Gathering into long gray columns, they walk, sometimes for many kilometers, their first real journey taken before they ever open their wings. Shepherded the whole way by the adults, the line presses steadily on, and the sight of all those chicks crossing the pale crust is one of the great quiet wonders of the living world. From far enough up, in the right light, the whole surface glows coral and rose with the color of all those birds. Quite possibly, this is the pinkest place on the entire planet, and almost no one will ever stand on its shore to see it. That, to me, is the quiet marvel of Natron. The most beautiful thing it does for an audience of itself. Now we arrive back at the riddle we opened with. A place can look, by every measurement we can take, like somewhere life should run from, and still turn out to be a stronghold. Natron is not a contradiction. Better to call it a lesson in how stubborn and inventive life on Earth really is, willing to settle into warm liquid soda beneath a brutal sun if that is the price of being safe. Which is exactly why the next part matters so much. This whole delicate machine depends on the water staying every bit as wild as it is, and that is far from guaranteed. Natron has faced threats more than once. Plans have surfaced over the years to draw soda ash out of it on an industrial scale, and to dam the river that feeds it from upstream. As recently as 2025, after a long public fight, Tanzania halted a major soda ash extraction project here, leaving only small, traditional collection along the shore. Conservationists counted it as a real victory, and it built on a much older one, since the lake was recognized as a wetland of international importance back in 2001. Pressure like this, though, has a way of returning, and the flamingos are tuned to one exact recipe, down to the salinity and the level of the surface. Nudge the inflow, soften the chemistry, raise or lower the water by even a little, and the salt islands that keep the colony safe can flood, or fuse onto the shore and open a path for predators. Should that balance ever break, the birds could not simply shuffle down the road. For most of the species, there is almost nowhere else on Earth left to go. Any lake that took a splitting continent and a one-of-a-kind volcano to build is not something good intentions can rebuild. So the next time you come across one of those photographs of impossible red water seen from space, do not read it as a warning or a wasteland. Read it as proof of something hopeful. Somehow, the most extreme lake on the continent is also the safest cradle for one of its loveliest birds. And both of those truths live in the very same water, on the very same day. Natron is what you get when a planet pushes a place about as far as a place can go, and life, against every reasonable expectation, looks at it and decides to call it home.